In the previous video, we have created a custom connector for our Copilot agent to use the FMP financial services. In this video, we are trying to provide the same functionality to our Copilot agent by using MCP. Now, MCP is an open source protocol that's been created by Anthropic about 12 months ago. It is a native tool to provide data services to large language model. So this is what we're going to use in this video. And let's compare the differences between the Power Platform custom connector and MCP. Previously, we have wrapped FMP Financials API in custom connector within the Power Platform. Now, similarly, we still need these APIs and we're going to wrap it differently by using the MCP. The difference is Power Platform custom connector is hosted within the Power Platform, but with MCP, you actually have to build it and host it somewhere else. It needs to be reachable. We will continue to use the API key for the simplicity of this demo. And when you create MCP server, it must be registered. So since we are using Copilot Studio, we're going to just host our MCP server within Azure. Now, Microsoft does not provide a method of how to create MCP server, but you can click on here. It's a open source project. This is the GitHub repository, and it supports a lot of languages. Now, C# is officially managed and maintained by Microsoft, but I'm more familiar with Python, and I think I'm just gonna go through the demo with the Python. If you click on documentation, you can see a simple instruction of what is MCP. MCP is a USB-C port for AI applications. But again, you can think of an API wrapper as well, because we still need APIs, and we are going to set it up as MCP server. For our use scenario, it's probably overkill. It's better to use a custom connector for the Power Platform to use with our Copilot agent. But if you're gonna, if you publish as MCP server, obviously as a vendor, you can just publish it and anyone can use it. Otherwise, the custom connector have to be created by end user, right? So this is just for demo purpose. It's not a best fit scenario for this FMP APIs to be used with Copilot agent. In the official doc from MCP, you can see here is a simple guide. How do you build an MCP server? You create an MCP server, and you can see all these language that it supports more than that from the other first page, but these are the examples they provided, and we're gonna use Python. And also this demo shows how do you build a MCP server to use with the client, which is the cloud desktop. For our use case, I'm gonna demonstrate how we're gonna build it using the VSCode, and that will be hosted in Azure Web Services and to be used with the Copilot Studio agent as the client. So we are using VSCode Agent mode. Or in the future, we can do another video comparing that to Cursor. So I just want to see how good this agent mode with VS Code it is. It's been out for almost 10 months now. Now, as you can see, I have created an empty folder and I open it. There's nothing here. And here is the agent. We always will start with a planning, and we're gonna paste our prompt. I'm gonna let agent to do as much as it can for us. The good thing is we already have the Swagger file from last video when we created the APIs as custom connector. So I just drag and drop here. So we are on the planning, and let's select a model. I'm on the Pro, so you have access to all the models, but Cloud Sonnet remains my favorite, so I'm gonna stick with that. Especially planning, Cloud's really good at planning. So let's go through these prompts together. I have uploaded the custom connector file in JSON format. Sorry. I have created a custom connector with this link is the financial FMP's website for Copilot Studio as tools. Now I'm going to build a custom MCP server with the same FMP APIs for the Copilot Studio. I've uploaded Copilot custom connector file in JSON format. I'd like you to build a MCP server exposing the same set of API actions as the custom MCP server, not connector. I like to use Python SDK, and MCP server will be hosted via Azure App Services. I'll just give a bit of directions. Here are some reference materials. So I just posted a few links for the MCP and just Microsoft. And let's see what it will provide us. If you ever wonder why your VSCode Agent mode does not create files, folders, and execute code for you automatically like Cursor AI does, you need to come to the chat window, click on Config Tools, and make sure you select these built-in tools, especially the one related to your workspace. Now, your agent will complete tasks for you automatically and autonomously. Next, because we know we're going to use Azure Web Services, so in the extension, I have also installed this Azure related tool, including the Azure MCP Server. It has an MCP Server for you to troubleshoot, so your agent does it for you automatically. Now, when it comes to the config tools here, I will select MCP tool, and I'll maybe select a couple more. We're not going through GitHub, so I will take the Azure's. And we are using Python, so I'll take Python as well. So Cloud has returned a very simple plan. Build a Python-based MCP server that wraps the 8 financial modeling prep API endpoints. It got that from our JSON file from the Swagger file. Deploy to Azure App Services for integration with Copilot Studio. It's going to create a folder structure for us. See, there's nothing here on the left. It's going to implement 8 tools that we want. It's going to be async, which is good. Using API, configure Azure deployments. Now, because we have all the extensions in our Visual Studio, and we have enabled those built-in tools, it should be able to do it for us, deploy the services to Azure automatically from VS Code. And then that's it. It didn't even talk about much about how we're going to use the Copilot Studio. I think that's the easy part. That's fine. So I like to test them. It is a local testing with Azure prompt. Okay, I'm going to test them at different stage. So let me add one more prompt. I like to verify the MCP server at different stages. Testing it locally first with MCP Server, MCP Inspector, so we can see it's working. Then we'll package it and deploy it to Azure, and we're going to test it with Postman, and finally with Copilot Studio. So let's send that. Let Cloud to finalize the plan, and then we'll hit start implementation. Okay, so the plan has been updated. We're going to test it multiple stages. And if you are happy with this, we'll hit start implementations. Now you can see the VSCode Agent has taken over the workspace completely and start populating files. And it stopped at this. It wants to read the JSON file we uploaded. I'm just gonna go allow. I'm gonna allow this in this workspace so it won't keep asking us. It only took a couple minutes. Looks like it's done. So we can see I have completed the MCP server. We've got a server.py. Looks like it's red, it's a bit of error. That's fine. Then we've got readme file. There's a tools we wanted, which matches the JSON file from our Swagger file from previous custom connectors. Next step, setup. And we're going to test locally, deploy. Okay, looks good. So let's tell the agent to deploy. Please deploy with step 1 to set up. Also, it didn't create a planning file, so let's create a planning file based on the planning you have done previously. Okay, let's go enter. You can see it's about to execute in virtual environment because Python, and we're gonna go allow this command. Now, one thing I noticed that VS Code does better or different from Cursor is VS Code is always gonna ask you for permissions when it executes command modify files. You can allow it for the session or for the workspace, so it won't keep asking you, but Cursor just does it automatically. So for VS Code, I think it put more emphasis on human in the loop. Some of you might like it, especially for the corporate enterprise environment. Make sure it always does what you need to understand. So it is going through a bunch of errors, and you can see it's still working through. So let's see how far it can push itself, and we'll get back to it. You can see our virtual environment has missing a bunch of packages, so it's trying to install the packages for us. Looks like it has gone through its own hurdles. You can see here the environment variable for the API keys setup has complete. I have successfully completed step 1 and then created the planning document. We can see the planning document here. Right, that's the planning document. And okay, so next step is asking us to provide API keys. Let's go to the environment variable. So we're gonna paste our own key here. Save it. Now, we can run the server now and also run the MCP Inspector to test these MCP endpoint locally, but let's see whether it can run for us. So I have pasted the API key in .env. Please run the server locally and the tests all 8 endpoints using MCP Inspector. And let's see whether it can run the code and test it for us. And then we can also have a look how we can test it ourselves manually. It has realized there was some errors in our server.py. As you can see now, the server.py that had a red 3 before is gone. Hopefully it has fixed it. The server is running. Okay, here we go. Now let's see whether we can test all 8 endpoints using HTTP calls. Let's see whether it can do that. So it looks like it's not using the MCP Inspector. That failed. Let me try a different approach. I will create a test script. Okay, let's give it a bit of time, and it looks like we need to test ourselves locally using the MCP Inspector. Okay, so it's been going on for 5 minutes, and you can see it keeps erroring out and going through the loops. So I'm gonna kill it. I'm gonna stop this, and we'll start a new chat. And let's say, show me, explain to me how to, so we'll change this to ask actually, how to launch the MCP server and use MCP Inspector to test it locally. Okay, let's see how we do that. Now looks like there's no obvious syntax error in our code, so we'll clear this. All right, so test your server locally. We're gonna activate it, and then we'll launch the MCP server. All right, so let's do that. We're already in the PowerShell, so let's just copy this. You actually have this file if you look into your folders on the left. I won't go through it. Next, we're going to launch the MCP server. Let's see whether it runs, because we have the server.py here. And let's do server.py. And we have error. So we can't test it before the server can run. So let's have a look at this. Error while attempting to bind on address. So it's something to do with the port and the local address. We'll change that to agent and let's ask, I have tried. Please see the error in the console, in the terminal. Now actually we can just have a look. Let's click on this. So do we get anything? Not found. So it is not running. Let's see whether they can fix it. It seems like it fixed it because it keeps saying that 8000 was used and it ran some command to kill a process, and now it launched again. And if you see here, it says it's running. So we just need to run the MCP Inspector, see whether we can access it. So let's test it with MCP Inspector by opening a new terminal. You can see here, we're going to paste this command in, and this will download MCP Inspector tool and launch it and connect our MCP. So let's try that. This is, hopefully it will run, and we'll get back to it. Again, more errors, you can see. And if you go back to the terminal, you can also see more errors. So let's see whether it can fix these errors. We'll take a screenshot of that. Well, actually, we can just copy and paste this. I'm getting errors from MCP Inspector UI. Here are more logs from the terminal log. Let's see whether it can fix it. We'll copy paste these and see whether it can fix it. Seemingly it thinks it found the root cause. Your server is using streamable HTTP, but MCP Inspector is trying SSE and it does not support streamable HTTP yet. So it created another file called server.studio to make it compatible as a standard input and output, and it wants us to test it again. So let's just do that. First, it wants us to stop the HTTP server. So let's go Control-C to stop it. And then we just simply go to the MCP Inspector and change the protocol to standard input and output, and it's a different file now. I'm going to do that, and the command is Python. Let's go connect. Let's see whether it does anything. Of course it didn't. Wait, actually it worked. Actually it worked. If you go to the tools and go list tools, yes, we can see all 8 tools. So it actually worked. Now we are ready to build and make it available in Azure. So let's go back here quickly and say thanks. It has worked with the ST compatible file with MCP Inspector. You can remove these files since we have completed local testing. So what I'm trying to do is I don't want it get confused when we publish this MCP server to our Azure Web Services. So let's get rid of other files and we can move on to the next stage. Then I realized in the drop-down menu MCP Inspector, actually you can see there is a streamable HTTP. which means it should support a stream over HTTP, not just standard input output. So I've challenged the agent. I said, you previously said MCP Inspector does not support, but I've showed a screenshot and says clear it supports stream over HTTP. Now we got a response back. It says the new one does support stream over HTTP and made some suggestions. Now from these errors, you can see when we try to run, so I just run the Python server.py again. When we run in the MCP server, you can see these endpoint SSE does not exist. And the AI Cloud 4.5 in this case has suggested try a different endpoint, MCP-V1. It also says not found, not found. Right, so it also said we do not need the header for the tokens because it is used internally. Your API keys does not require to be provided again in the MCP Inspector. So that's fine. I did a bit of test. Clearly SSE is not correct. V1 is also not correct. But when I added a / without V1, and I have removed the authorization and the token, and we'll go connect again. It actually worked. So we did not need that standard input output file. Our streamable HTTP server is all good. If we go to the list tools, we can go list tool again. You can see it's all there. And if we want to test them, let's say we just put a apple. So I think it's AAPL. Let's run the tool. And success. We've got all the responses back. Okay, I think we are ready for the Azure deployment for the web services. Okay, so we are putting our final prompt in. I have tested and the correct path is the one with the /. Please update the code as needed and we'll get ready for the Azure deployment. And once you update the code, we'll start a new chat. When you use AI to develop codes, it's a good practice to have them break into smaller chat, and I like to break them into based on the features. So now we finished building the MCP server, complete local testing. The next thing we're gonna do is have a new chat to start the Azure deployment. Go new chat. This is part 1 of our 3-part series of how we can build MCP server, have it hosted, and eventually use it with our Copilot agent as a tool. Now for our use cases, this is probably not the best to use an MCP server. A custom connector will serve the purpose for our Copilot agent. But there are a lot of use cases that you should use an MCP server. For example, internally, you will be exposing your APIs from different systems for your developers and different teams to use. In the past, you will be exposing them using an API gateway. Now you will probably just want to build 1 or 2 MCP servers to expose a bunch of APIs for your services and have them published instead of individual APIs. So there are definitely a place for MCP server, and it is native. It is a native way of exposing services to large language model. So in our next video, we will be publish our MCP server to Azure as a web app, and we'll see you there.